So 1025. Vertical and horizontal particle motion. Let's see. So vertical's up and down, horizontal's left and right. The difference is vertical usually has one equation to deal with, although they'll usually give it to you. That's what you did in physics. A lot of the distance equals 1/2 AT squared plus V0t
2D dimension. 2D.
Plus D0 or S0 or X0. I may be using different variables, but does that look familiar from physics?
Delta X equals 1/2 AT.
Yeah, sometimes you use delta X and then you don't need a D0 because you're measuring the change. Horizontal, your position will just be given to you. They'll just give you an equation and says it tracks out this position, and that way they can make it any function they want. So there's a lot of times it's horizontal because then they can throw cosines, natural logs, and all the crazy stuff in there.
Sometimes.
If you do vertical, you're sort of limited to that physics equation. All right, in general, t is time, but t could represent anything. So, pay attention. That's always a good rule. But pay attention to t's restrictions, because sometimes they'll say for t greater than 0, or if they want to get tricky, t between 2 and 5 or something. If t represents time, can t be negative?
Mm-hmm.
I think instead of yes, enthusiastically, I'd say rarely, but possibly. And the example is, if t equals 0 represents noon, then what t would represent 2 hours before noon? Well, probably -2 if t was in hours, although -120 if it's in minutes, so again, be careful. S of t is frequently used for the position, but it could be other variables like x or d. Like I heard you say delta x or x0, so it could be other things, but usually it'll be s. Sometimes if we want to differentiate between horizontal, we'll use x, y for vertical. That's pretty standard for physics, right? Because you have v sub x and v sub y when you're talking about which way you're going. So that should be familiar. V, okay, here's the big deal for us. V equals s prime. V equals ds dt. And if you think about what ds dt means, I think it's clear that that's velocity. Change in position over change in time. So how far you went divided by how long it took you to get there, that's velocity. A is the first derivative of v, because that's change in velocity over change in time. In physics, one of your physics questions, hesitate to write this because we don't use this in calculus, but Vf minus Vi over t, does that look familiar? So that's an average acceleration though, so be careful. That's an average slope. That's an average rate of change. That's an algebra slope. So we're not going to really be using that because we're going to use derivatives. dv dt, not delta v over delta t. But that's how they're related. All right? Speed is the absolute value of velocity, meaning that speed is never negative. Speed cannot be negative. Speed is never negative. Here's some things that you might remember from physics. The particle is at rest when the velocity is 0. You remember that from physics? You use that a couple different ways in physics. Like if you throw something up in the air, you figure out when it gets to the top, because at the top the velocity is 0. Just for a moment, just for a split second, then it starts going down, but just for a moment velocity is 0. Particle moves to the right or up when velocity is positive. Okay, I think that makes sense. We're used to moving right is positive or moving up is positive. Left or down is when v is negative. Displacement versus distance. This is another physics thing. The displacement of the particle on the time interval a to b is the value of your ending position minus the starting position. It's just where you started, or excuse me, where you ended minus where you started. So it could be negative.
Like you could move to your right and then move back, and your displacement would be 0, but your distance wouldn't be.
Right. So if you run a lap on the track, I don't have any place to write this. If you run a lap on the track, you run 400 meters all the way around, you end where you started, what was your displacement?
0.
0. You didn't go anywhere. Your final minus initial is 0. Your distance, though, would be 400. Okay, if you did it 4 times, your distance would be a mile. Your displacement would still be 0. So that's the easy thing to think about with displacement versus distance. When we start to do integrals, which we haven't done yet, so this doesn't mean a whole lot. Yeah, let's just pass over that because you don't know what that means right now. So we'll come back to that later.
I thought we were about to start integrals.
No, we've got to get through all their derivatives first. To find the total distance traveled, there's usually not a shortcut to do this. You have to find the sum of the total distances to the right and the total distances to the left.
Tip to tail.
And kind of add them up. Well, I went 5 that way, and then 3 backwards, and then 2 that way, and add them all up, and I went 10. But there's not a shortcut way to get that.
Yeah.
And we'll see an example where you literally draw it out to keep track of. I walked 5 that way, but then 8 backwards, and then 12, and you just have to draw it out to keep up with it. Now, when we get to integrals, there's a better way, but we don't do integrals yet, so
Yay.
we're not worried about displacement versus distance integrals yet. Number 7. To find when the speed is increasing or decreasing, we need to know where speed prime is positive or negative. But speed prime is the derivative of the absolute value of velocity. This is like weird to think about. Taking derivative of absolute is complicated. So don't worry about the complication. Here's what we need to know. Always a question on this on the AP test, because it's easy to write one where a good multiple choice question where it asks where is it speeding up, where is it speeding down, slowing down. The particle is speeding up when velocity and acceleration have the same signs. And the particle is slowing down when velocity and acceleration have different signs. So let's think about this. When velocity is positive, that's when it's easy to think about. Trying to make a table here. I can't figure out how to draw a good table. So if velocity is positive, you're moving forward. If you press the brake, so let's think about your car, your velocity slows down, you start slowing down. And your acceleration is negative. Velocity is positive, moving forward, press the brake, you slow down, your acceleration is negative. So you got V positive, A negative, that means you're slowing down. That's the easy one. The other easy one is if your velocity is positive and you press the gas pedal. Then you accelerate, you go faster. The trickier one is if your velocity is negative.
That means you're going backwards.
So you're going backwards.
Like you're backing out of your driveway.
You're backing out of your driveway. Let's do what I think is the easier one first. Let's say you press the gas. So intuitively, you're backing out of your driveway, you press the gas. Do you speed up or slow down? You speed up. You press the gas, you speed up. So you speed up. But what is your acceleration if you're speeding up in the wrong direction? You're speeding up going backwards. Your acceleration is negative. So if your velocity is negative and your acceleration is negative, then you are speeding up. Again, that's kind of the weird one because it's like, oh, they're both negative. Why is this one positive? When you're speeding up in the wrong way, so your acceleration is negative, your velocity is negative, and you're speeding up. The other weird one, this is probably the weirdest of them, is if your velocity is negative, which means you're moving backwards, and you press the brake. So you're backing out of your driveway, you've backed all the way out, so you start to hit the brake so you don't hit, the neighbor's mailbox back there. So you know you're slowing down because you pressed the brake.
But in that case, your acceleration has to be positive.
But your velocity is sort of tending forward, like you're being pushed forward. Even though you're going backwards, your velocity is trending forward. So your acceleration is positive. Because you're trending in the right direction. You're being pushed in the forward direction. Well, if your velocity is negative and your acceleration is positive, they're fighting each other. So you're slowing down. Now, whether you can think through that or whether this is one of those things that's like, I just got to memorize. This may be one where we'd rather you understand because then you can apply it more. But this is one of those places where some students are like, yeah, I don't get it. I'm just going to have to memorize this one and move on. If V and A have the same sign, you're speeding up. If V and A are fighting each other, then you're slowing down. That's the way I think of it. So if your velocity is negative, but you're speeding up, you're in conflict, you're slowing down. If they're both pointing the same way, you're speeding up.
You can think about it like, I know we have to talk about politics, but like with the house and
Oh
stuff.
boy.
Like,
Let's hold off on that. Let's do an example. Today is going to be all no calculator. We'll switch to calculator tomorrow because there's a lot more things we can do, but we need to make sure we understand it before we grab a calculator. The position of a particle that is moving in a horizontal line is given by the equation S of t equals t cubed minus 6t squared plus 9t. T is in seconds, t is greater than 0, so no negative t's, and S is in meters. Okay, so this is very straightforward. They tell us the position. They ask for velocity. But we know that velocity, whether in physics or calculus, is change in position over change in time. So let's find S prime. Not often we get to pull a popsicle stick when we're going over something new. So we'll take the opportunity and ask Ty to tell us what the derivative is. Yep, that's all it is. So it's an easy problem, like the mechanics of it are easy. It's just do you understand what they're asking? Find the velocity of the particle at time t. That's it, because the velocity is derivative of position. What is the velocity at exactly 2 seconds? So I want the velocity at 2 seconds. Thoughts on what we could do to find the velocity? Plug in 2. And safe stop, time saver, and algebra saver. Like, we're good. That's it. That's my answer. Whatever that is, that's my answer. Velocity at 4 seconds, plug in 4. But I would say make sure you label your answer, especially on these questions where there's 2 questions in one. Some people are going to calculate what that is, and they're just going to write down, I don't know what the answer is, but they just write down 12 and 37. Like, what's 12, what's 37? You need to communicate what you're telling me. That goes for up here as well. Don't just write 3t squared minus 12t plus 9. You might get credit on that one because it's the only thing that's asked, so you're probably okay. But it would be much more helpful if you would say v equals or s prime equals to tell me what that is. Part C, find the acceleration at time t and at 4 seconds. So we said the acceleration was the derivative of velocity. So Mia, if I look at my velocity equation and take its derivative, I'll get acceleration. So what's acceleration?
6t minus 12.
Good. 6t minus 12. Callista, how do we find acceleration at 4 seconds? Plug in 4. So a of 4. But again, make sure you tell me what you're doing. A of 4, 6 times 4 minus 12.
Could you have written the evaluation line and written like t equals
Like
4?
a when t equals 4?
Mhm.
Yep. Or you could have written it as dv dt when t equals 4.
Okay.
Either one of those. Indicate units of measure. We could go through the derivative stuff to figure out the units, but I'm guessing you know the units of measure from your physics time. What's the units for acceleration?
Meters per second squared.
Meters per second squared. Part D, when is the particle at rest? So what am I looking for? What does at rest mean?
Vt equals 0.
So justify your answer. I think I just justified my answer. V equals 0. That's going to justify my answer. Oh, did it say?
No.
It didn't specify units, so it wouldn't take off if you didn't do it. Like, when they say indicate units of measure, you can bet that there's a point attached to you putting the units on there. And so yes, it would probably be better if we included it, but if they didn't ask for it, we don't have to give it. All right, when's the particle at rest? Well, when v is equal to 0. So I justified already. When v equals 0, the particle's at rest. Oh. Please let that factor, so I don't have to use the quadratic formula.
I just pulled a...
They were kind. They were kind to us. T equals 3 and t equals 1. When is the particle moving to the right? When is it moving to the left? Justify your answer.
Wait, so for the last one, the work justifies the answer?
I think the work plus saying v equals 0 justifies the answer.
Okay.
Because rest means v equals 0. That's what they're wanting you to do. And then after that, the work plus saying v equals 0 justifies your answer. When is the particle moving to the right? Particle moving to the right, that would mean where v is positive. Moving to the left, that means v is negative.
Is that...
I'm sort of working on my justification here. It's not quite enough, but I'm on the path. I found where v is 0. So
Found your critical point.
those are my critical points. Those are where it changes direction, or maybe changes direction. I say maybe because it could go forward, stop, and then keep moving forward. So let's do a number line with 1 and 3. And so we'll do V of 0, V of 2, and D of 4.
Well, we already found V of 4 and V of 2.
That's not an accident. On these type of problems, they will frequently kind of help. You don't know it at the time, but they're helping you out. You get here and you're like, oh man, I got to find V of 2. Well, wait a minute, they already asked me for V of 2. Except I was lazy and didn't calculate it all the way out, so I don't know if it's positive or negative yet. 3 times 4 is 12, minus 24, plus 9
Is a number.
is negative.
Yeah.
And that was V of 2. V of 4, 16 times 3 is 48. Minus 48. Oh, they made the math easy on that one. Equals 9, so that's positive. V of 0 isn't hard to find. You plug in 0, you get 9, so that's positive. So V is positive, negative, positive. So let's make sure. When is the particle moving to the right? So again, make sure it's clear, especially when there's more than one question per question. It's moving right. You know what? I'm going to justify first. When V is greater than 0, and that happens less than 1, but we had to start at 0, so from 0 to 1 and 3 to infinity, because I don't think it didn't have a stopping point. And it's moving left when V is less than 0. That's my justify, and that happens on 1 to 3. So you can, I hope, see how this ties with optimization. Take a derivative, set it equal to 0, figure out where this is a first derivative test. Where is it increasing, decreasing, increasing? Draw a diagram to represent the motion of the particle. Okay, so it's moving right from 0 to 1. It's moving left from 1 to 3. And it's moving right from 3 to infinity. So I need to find all of those positions. S of 0, S of 1, S of 3. I don't guess I need S of infinity because who knows?
It's a big number.
A big number. So I plug those in, and S of 0
Is 0.
is 0. That's nice. S of 1, let's see, I'm all the way back. I'm looking at my top equation for S. 1 minus 6 plus 9 is 4. And then S of 3,
Yikes.
27 minus 54 plus 27. It's totally a rigged problem here, but that worked out.
0.
So here's what a motion diagram looks like. We're going to try to draw this, not necessarily to scale, but at t equals 0, we're starting here, we move to the right until t equals 1, and s equals, what do we say, s equals 4. Move my face out of the way. And then from t equals 1 to t equals 3, we're going backwards. And s of 3 equals 0, so you can put it all the way back. I'm trying to just trace out what the particle did. It moved to the right by 4 units in 1 second, and then it moved to the left 4 units in 2 seconds. And then after that, it just took off and went to the right. The motion diagram is sort of a different picture to try to visualize what the thing's doing. That's usually the hardest thing in the unit, honestly, I think. You gotta know S, you gotta know T, you gotta know which way it's going, and you gotta draw it in some way that makes sense. G. Find the displacement of the particle during the first 5 seconds. So now I'll need to find S of 5. But all I've got to do for this is S of 5 minus S of 0. So S of 5 is 125 minus 6 times 25 minus 9 times 5 minus 0, because I already know S of 0. And I'm going to leave that as my answer because I don't want to do that.
But would it be meters?
And it would be meters because S is in meters. I do need to say the units. Find total distance. Well, here's where that motion diagram is going to be real helpful. So there's lots of different ways to do this. But I would just look at the picture during the first 5 seconds. So from 0 to 1, and then from 1 to 3, and then 3 to 5, and just kind of add up the pieces. So how far did it go from 0 to 1?
4 units.
4 units.
Plus 4.
And then from 1 to 3, well, I don't care about negatives because all I want is distance.
Oh, yeah.
So we went 4 more units. And 3 to 5, oh, this is why they asked me S of 5 down here. So I do need to find S of 5. Tried to shortcut things. 125 minus 150 minus 45. Oh no, that should be plus. It's because I wrote the equation down wrong. So what is that? 170 minus 150 is 20. So I could add that to my diagram if I wanted to. So from 3 to 5, started at 0, landed at 20, so we went 20. So you add up the 3 pieces and we get 28. When is it speeding up and slowing down? Well, we already have our velocity picture. Plus, minus, plus. We need an acceleration picture. The only difference, the only change with it too, I'm looking way back at acceleration. It's about to ring. But acceleration is negative to the left of 2, positive to the right of 2, and we'll try to figure out the rest tomorrow.
You mean Thursday?
I hit record.